Hi, welcome to the analog sensors tutorial. My name is Alexei and I'll be guiding you through this tutorial. By this point, hopefully you've completed the LED tutorial and the I squared C sensors tutorial. So by this point, you're pretty comfortable with hooking up sensors onto breadboards and loading up Loom code onto Arduino. So I probably should have addressed this a little bit earlier with just sensors and hooking them up. But as you can see here, this sensor is it's a little weird. It's not like like some sensors in the lab where you can easily sliding it to a breadboard. So yeah, like you have two protruding parts that you just can't put headers into and then just stick them into a breadboard. So when you have situations like these, you're going to want to use headers and some wires. If you don't know what headers are, I'll put up on my screen. We have here some male headers, and then we have female headers. So yeah, you put the male headers into the female headers, vice versa. Okay, so yeah, back to what I was saying with the headers is that you're going to have to find and cut some wires to directly solder onto the headers. So here in this sensor, you can see that the header is soldered onto the PCB, and then you have three wires that correspond to the ground, to power, and to the analog output pin. And they're soldered on this side, and then you have another header on this side that you can connect into your Feather MO board if it has a female header, or you can stick into a breadboard like I have in my little configuration here. So yeah, when you have sensors like these, you're going to have to get a little bit creative with putting up wires and soldering them. If you don't know how to solder, I'm sure there's people around you who know, and usually someone in the lab knows how to solder. So you can ask them, and there's plenty of videos online on how to solder. So let me talk more about the datasheet of this sensor that I'm working with. This is the MB1220 sensor, and I think you can find this in the lab. And as you can see here, the datasheet is super important. So when you're hooking up the sensor, you're not soldering wires onto the wrong headers. So as you can see here, the datasheet tells you where you can solder the ground wire, the supply voltage, and the analog pin wire. So this is the configuration for the MB1220 sensor. Another analog sensor that you can find in the lab is the Teros 12 sensor, and this is what it looks like. It's pretty much it collects data from the soil, as you can see here. And then if you look at its datasheet, this is the wire configuration. So traditionally, it comes in a stereo plug connector. Obviously, you can't stick that into a breadboard or hook that up into your computer and use Arduino. So what you're gonna have to do here again, you're gonna have to be a little creative, and you're gonna have to get a wire cutter, and you're gonna have to cut into the wire and expose these three wires. The power, which it'll tell you what color it corresponds to. You're typically gonna have the power, the ground, and then the analog communication wire. So yeah, and again, similar to this configuration, you're probably gonna have to get some wires. You're gonna have to solder some wires into male headers that you can then plug into a breadboard. So yeah, once you have your configuration and you've set up your sensor properly, now you can begin with the software side of things. All right, so at this point, you've set up your analog sensor to your breadboard or the configuration that you've made on hand. One thing that I like to do when I'm working with new sensors and I'm not familiar with the Loom code for the sensor is that I like to find Arduino code online, just example code that you can find from resources. And as you can see here, I found some example code from the internet. And it's a good practice to look through the code to understand it so you have a general idea of what's going on. So again, to upload this code to your sensor, you're going to want to go to this arrow here. It's going to upload, or it's going to compile the sketch and then upload it to the board. And then afterwards, you want to make sure that you reselect your board, your Lumified Feather MO board, to the USB port that you have your MO board connected to. So now you go to the serial monitor, and hopefully you have some data displaying. If you don't, that means your circuit configuration is incorrect. As you can see here, I have a ultrasonic sensor that just, right now I have my hand really close, so the distance is decreasing, and then the distance is increasing as I wave my hand farther and farther away. One thing that I've experienced with analog sensors and the Arduino code that I found is that the Arduino code, it still runs and outputs data to you even when your sensor is not hooked up properly. I was working with the MB1220 sensor, and I had a wrong configuration, but the serial monitor was still displaying data. But a little hint that you know that you're not doing, that you haven't set up your configuration correctly, is that the values of the data are just really weird. So when I was having issues, my distance was like 100 or like 800, and just crazy numbers that just aren't really feasible in in this context. So when I did get it to work, as you can see here, the values are a lot more reasonable, and they actually line up with, like, if you have a gesture sensor, you're waving your hand closer, the distance is going to decrease. So yeah, that's also one thing to know. Sometimes the code is going to work, but your sensor configuration isn't. So you just want to keep a close eye on the data that is outputting. And if your data is a little weird, maybe that's a sign that you haven't hooked up your sensor properly. And now we're going to hop over to the Loom code for the sensor. All right, so by this point, hopefully you're pretty comfortable with the Loom code and finding your sensor example code on the GitHub page for Loom. So as you can see here, I've navigated to the Arduino code for the analog sensors. And as you can see here, we have the same Arduino code across for all analog sensors. And as you can see here, this Arduino code follows that same structure that many other Arduino codes that we have on the GitHub page. It has the manager begin serial and the manager initialize and the void setup. And then in the loop, it's just measuring your data, packaging it into the JSON file, and displaying the JSON file onto the serial monitor. And the only difference that we have in this on this analog Arduino code is that you have to specify which pin you're reading from. So how they have it here is it's going to read from A2. In my case, as you can see here in the Arduino code, I have it reading from A4, which is what I have connected to the analog pin to the sensor. And yeah, let's just take a look at the serial monitor. Data should be displaying. Let's give it a second. But yeah, it's usually really good practice to look through this Loom code and really understand what's going on. I had some issues understanding the code here initially with the analog sensors. So as you can see here, I kind of added an extra function, and I got this function from just example code online. And I just wanted to compare the values that this function was giving me to what the Loom code was telling me. So as you can see here, we have the JSON document being displayed here, and you have your typical manager. Yeah, this all looks the same. And then the part of the data is shown right here. So this line right here, the A4, tells you the data being read from the analog sensor, and then the A4MV is just telling you the millivolt reading from the A4 pin, and then the VBAT is just the voltage reading from the Feather MO board, and then it tells you that same value in millivolts. And as you can see here, this function that I added from the read sensor, it tells me the data that I read just using the analog read Arduino function. And as you can see here, it is very similar, the read data, my function, to the data that was taken from the Loom function. The only difference is here is that um, they weren't measured at the same time, so they're slightly different, but they're pretty much the same. So yeah, if you don't know what's going on with your code, just play around with it like what I did here, adding functions and then just comparing the values that you get from your functions and the values that you get from the Loom functions. Also, you can head over to the source code for the analog for the analog sensors, and you can see here exactly what's going on. In the measure, it's pulling the battery voltage and adding it, and then it gives it to you analog to MV, converting the reading to just millivolts. And yeah, whenever you're feeling a little confused with the Loom code and you're not entirely sure what's going on, just make sure that you look through the implementation file on GitHub and play around with the Loom library documentation page that we have that you can find on our GitHub page.